Hello everyone. So today we're going to be looking at the product rule, which is used to differentiate two functions multiplied together. Just a reminder that dot means multiply. So far we've only been looking at individual functions differentiating. So I've made the list of all of them over here. We've had all of our trig functions. We've also had e, we've had ln, and we also just have our regular power functions like x squared or x to the 7 and stuff like that. And we've differentiated each of them individually, but what happens if they're being multiplied together? So this is where the product rule comes in. Sometimes it can be hard to tell if you have a product rule. A good kind of rule of thumb is if you see an x in two different places and it's not in the same bracket with each other. So that's not two different functions. For starters, they're being added together. If you see an x somewhere and an x somewhere else and they're being multiplied, then usually you'll need to use the product rule to differentiate it. So it would be nice if we were trying to differentiate something like this, then we just differentiate e, we differentiate that, and our final answer is multiplied together, but that is not the case. It doesn't work like that. Maybe when we're back in class I can show you some examples of why. Today we'll just look at the actual product rule and how to do it. So the product rule says if we have some y or some original function that equals to two things being multiplied together, to differentiate that, we differentiate the first one and multiply it by the second one not differentiated, and then we add the first one not differentiated multiplied by the second one differentiated. So f dash times g plus f times g dash. So quite often it's abbreviated to this. We don't put all the x's in because it can take quite a long time to continuously write that out. So it's just f dash g plus f g dash. So I'm going to be using this formula. It's a little bit quicker and easier. So let's do some examples. It's not that hard, but people do make mistakes. So we just got to try and take our time, do it properly. So in this case here, what I'm going to write is I'm just going to write what my f is and what my g is, and I'm also going to write what f dashed will be and what g dash will be. So you don't have to do this every time. I suggest at the start when you're practicing this, you do it this way. You write the four things and then just simply put them into the formula. So f, it actually doesn't matter which one you pick to be your f or your g, you just have to pick one or the other. So I'll just do it in the same format. So f is going to be my e to the power of x, and g is going to be my x squared. Those are my two functions, e to the x times by x squared. So if I differentiated e to the x, that just becomes itself. That was the amazing one, that when it differentiates it becomes itself. And x squared will become 2x. And now I just have to put these four things into this formula. So for me, my derivative y dash will be f dash times g. F dash was e to the x, g was x squared, plus f g dash. F was e to the x, g dash was 2x. E to the x times by 2x. And that's my final answer. Good. We're not going to do anything with that. That's fine. That's an acceptable final answer. Alright, second one, getting a tiny bit trickier, but not too hard. I'm going to do it the same way again. I'm going to write it all out. So I've got f, g, f dash, and g dash. Just make sure everything's in the screen. Alright, so in this case my f is cos of 3x. Don't panic too much that I've written this one as f of x and I'm using f. It's not a major concern. G is this bracket here, these two things being added together. They're not multiplied, so that's fine. So it's 2x3 plus x. So when I differentiate cos, by the way, you are given in the exam a formula sheet that looks very much like this. So you don't need to memorize everything. You can just, you mainly just need to know how to use it. You don't need to memorize any of these things. So cos of 3x, cos goes to negative sign, and remember we have to multiply by the derivative of that inside bit. So it's going to be 3, or times by negative sine 3x. Or in other words, negative 3 sine 3x. G dash, differentiating this, going back to just year 12 differentiation, it's going to be 6x squared multiplied by 3 at the front, and x is going to become 1. It's like there's a 1x there, which becomes 1. Alright, so putting this all into my formula, it's going to take up a bit of space, so I'm just going to go below this. So we're going to have f dashed of x equals to, using my formula, f dash g, negative 3 sine 3x times by g. There's two things here, so I need to put them in a bracket. 2x cubed plus x, and plus f g dash cos 3x multiplied by, again there's two things, so I'll put them in a bracket, 6x squared plus 1. Final answer. Let's do one more example. I'll just put the formula up here so you can see it. F dash g plus f g dash. Alright. So, last one. I'm not going to write the formula out this time. The f, the g dash, the thing. I'm just going to do it using the formula. So I know that that thing there is my f and that thing there is my g. So straight away I'm just going to go straight to the formula. F dash, differentiating that, it's going to be 2 times by 1 over x, which we can just write as 2 over x. Multiply that just by tan 4x. That's my f dash g. Add on f, which is 2 ln x, times by tan 4x differentiated. Tan goes to sec squared. Remember, I have to times by differentiating that. So 4 sec squared 4x. That was my f, and that was my g. Alright, hope that helps. Let me know if you need any more help.